Next, we have Artem Blagodarenko. God damn it, I'm so sorry. I did it beforehand. Blagodarenko. He works for Seagate. He's a software developer in the LDISKFS team of Seagate. He's been involved in the community since 2011. He's received his PhD in computer science, and today he's going to talk with us about scaling LDISKFS for the future. Artem, thank you. Let's give him a hand.
Thank you, Steve. Good afternoon. So, scaling LDISKFS for the future. Actually, scaling is useful right now. And this talk is about why and how. Okay, there are two backend storages for Lustre right now. There are many presentations about ZFS on this conference. It has many advantages like large scalability, asynchronous support, and copy on write. But people like talk about this, but people still use LDISKFS because it has very long story and based on nice file system ext4, and I think it's still actual. So LDISKFS is fine backend, but sometimes it needs some attention. And now it's such time. Because hard drive vendors product new hard drives, it's become bigger and bigger. And if such new hard drives installed to the same old racks, the amount of such targets or such storage become very large. And now such large targets exceed the original design of ext4 and LDISKFS, because LDISKFS based on ext4. It's not a problem. It can be solved. Currently, if you decided to format very large disk with type LDISKFS, you can get a message, stop do it, it's very dangerous. You can get data corruption. But you can use force option and do it on its own risk. I believe nobody uses this option in production, I hope. But this option can be used during the verification process, and it must be used. So what the right algorithm I see is set. Now this option looks like force 128 terabytes. And we have targets that exceed this limit right now. So what we need to do, we need to set this option, then test and verify locally such a great configuration, and after all verified, we can set new limit and share this limit with community. So everybody else can use LDISKFS for large system without any thing. So what possible troubles can be? So I believe that we can use last format parameters without optimization, without changing, because they are was set for in good last times then there were no such large devices. Also, probably LUG structures doesn't ready for such large data. Also, LDISKFS and ext4 structures should be verified. Testing, we need first create such device and do some operation. Has anyone tried to create such a large partition? I think no, because if somebody tried it, it should move this limit to new size. Also, LUG tools should be ready. So if we sometimes face it with any troubles, LUG tools should save us. Some parameters written by default in LDISKFS. Some of them can be passed during makeFS operation. So if we try to create new partition with LDISKFS, we can see such parameters. So from first view, we see that many nice ext4 options are used that solve many possible troubles with large data. For example, extends are enabled. Dir and link, huge file, 64-bit. But some parameters can be dangerous or can be can be changed. For example, inode count per bytes rate. It is a parameter that set how many bytes we used for one inode. So it's this parameter are set by default if we are not applied I option. It can be and can be not optimal. At the bottom there is calculation for 169 terabyte partition with a default value of 1 megabyte rate. We have near 2 giga inodes. Actually, X4 limited by design to maximum into 32 inodes. So every time we set this parameter, we need thinking that inode count should be less than this count. So smallest value for such large partition as 169 is only 43 kilos. Also, this limit how much OSTs we can use, because for worst case with one stripe, there's only 24 OSTs we can use. So we can enough inodes on MDS. So we should always remember about this parameter, then adjust the cluster. Another option is flex BG. It's very, it can be useful because in large devices we can see the performance degradation at the end of a disk. So, but there is nice option that that can move metadata to a special part of disk. And we can adjust how many groups of metadata they move to this special place. This is G options, but it is written by default inside the LDISKFS. But we added such options to MKFS utility. You can adjust it now. There are scalability issues. We have very large partitions, and probably we want to write many files or directories on such large partitions. We can face with some troubles. For example, with the current design, we can store only 20 million entries in one directory. And with, if we write the files or directories with the same name or with a similar name, there are possible some collisions that reduce the number of these entries. Currently, we see that the solution can be increased hash tree levels. I know that Andreas knows about this. It's not so emergency right now, but in the near future, it is very useful. Another use case is creation plus unlinks. That tree should be shrinked after many such operations. So it's another point to solve in the near future. So during verification, during code review, we read all disk data structures. Everything looks fine. There are two types, one for global block addressing and another one for local block addressing. So there is only not some little troubles, not dangerous actually. For example, in this example, this function, wrong parameter type is used. It's unsigned long, and there are sector T values passed. Possible troubles can be in x86 platform, but this place already patched and sent upstream. Another LUG structures that was reviewed are extend attribute, quotes, and LUG. There are no dangerous problems there, so everything fine. Tools. FSCheck has two types for addressing blocks, and there are some wrong using of such types, but in the subsystems that actually are not used in Lustre. For example, bad blocks, nobody use it. Third translator or bitmap layer extends, I use it actually. And on next step, we tested such a large partitions. Next steps, first partition is created and verified that kernel can read and write this. After that, LDISK partition is created, and some basic operations are checked. Then this LDISKFS mounted as Lustre, and all existed tests from Lustre test suite executed. So and this show that no large troubles exist. So we tested Lustre, LDISKFS, and Lustre tools. There are some special cases that were found during inspection. For example, 46 kilo subdirectory limit would solve this special ext4 option, but we are not found appropriate test in Lustre test suite, and adjust existent to test this case. Also, we tested that we can create inodes to upper limits. Tested MKFS lazy init and performance at the end of the disk. As a result, for customers, it is as a result customers can get fewer OS tests or same OS test count, larger OS tests. This allow to make denser storage and save hardware, save place. For community, we finished this code review. We adjust the testing suite. We send upstream patches and fixes. And currently, we uploaded the patch that asks, can we move this limit to new size to 256 terabytes. So if there are enough steps, enough actions, we finish it, we can move it. Currently, new hard drives arrived and new problem. So we need to solve. We need to think about next step. We need to move limit upper 256 terabytes. We will prepare the same steps and will add some new steps. During this project, some ideas come to us. I think that this limit, inode count limit, it is time to extend it because it is not enough. Also, we need to invent solution for large directories and check large memory blocks allocation because structures become very large. Thanks to Alexey Leshkov, who gave many ideas, Elena Reznova for testing, and Megan McLean. Thanks you for attention.
Questions for Artem? Oh, Andreas?
So one of the reasons that we haven't looked very hard at increasing the inode limit above 4 billion is because checking a file system that gets so large takes a long time, right? And I think there's more interest in going to, DNE and having multiple MDTs separately. Do you think that it's practical to have a file system with more than 4 billion files in it on the MDT?
Actually, DNE can solve this. Yeah. Probably someday I can't use DNE or have only one MTS and many OSTs. I don't know, but it's a nice objection.
Anyone? No? Artem, thank you very much.